Hi, my name is Lindsay Kibler, and I am a Materials and Process Engineer with GE Additive. We'll be addressing the myth that alloys need to be traditionally weldable in order to be considered for additive manufacturing. So when we talk about weldability, the main things that we're addressing are the chemical composition of the alloy and how prone it is to cracking under certain thermal loading conditions. So when we consider laser powder bed fusion, it really is essentially one big weld. So a lot of the process variables and inputs are similar to that of traditional welding. However, with laser powder bed fusion, we're on a much smaller scale. So we're printing in a layer by layer fashion, and those layers are only on the order of 25 to 75 microns. Whereas with traditional welding, like a TIG welding process, the scale is much bigger. The parts are much bigger, and your weld joint itself is a lot bigger. So it's a lot easier to manage on a smaller scale because you don't have as much thermal fight going on between the larger components in a traditional welding process. So we can adjust a lot of those variables like power input and speed, dwell time, and plate preheating to get the most favorable properties and the most favorable process for a given alloy. We can also adjust the chemistry slightly so that we can minimize the elements that are going to be detrimental to the process. One really good example is considering stainless steel 316. Typically, in additive manufacturing and in laser powder bed fusion in particular, we use 316L, which is a low carbon version of that alloy, and that helps the welding process.